Hello guys, welcome to Pepcoding, and now we are going to discuss the next question, that is complete binary tree insert. Okay, so in this question we have been given one complete binary tree, and what we have to do is we have to insert the element in that complete binary tree. Okay, so let's see the question first, and then we are going to discuss the approach of this. Okay, so our question is CBT, that is complete binary tree. So first we are going to understand what actually the complete binary tree is. Okay, then we are going to come into the actual part. Okay, actual question part. Okay, so complete binary tree is that tree in which all the older levels are filled. Okay, which all the lower levels are completely filled. Okay, that means all older levels are completely filled. And what is the next condition for CBT is all the nodes to the left are completely filled. Okay, so for CBT these two conditions are mandatory. So let's understand with the help of example what actually these conditions are. Okay, suppose this is our tree, one is there, then in the next level, that is 2, 3 is there, next in the next level, that is 4 is there, and 5 is there. So is this tree is a complete binary tree? Yes, this is a complete binary tree. Why? Because all the older levels, that is this and this, are completely filled. Okay, and all the element to the last node, to the left of the last node, is also completely filled. Okay, so let's understand for some more examples, that is 7, and suppose this there is 8, and suppose there is 9. Is this a complete binary tree? Let's see. So when we see this condition, that means all the levels are completely filled. That is true, but the from the last node to the left side it is blank. That means we can insert one node in this place. So this is not a complete binary tree. If there is any vacant place to the left side, then it is not a complete binary tree. So for complete binary tree we have to insert 9 to the left side. Okay, so first it is going to fill the left side, then it is going to fill the right side. So these are some rules for complete binary tree. Okay, so let's see further. Suppose 9 is there, 10 is there. So is this a complete binary tree? Yes, it is a complete binary tree. Is this a complete binary tree? No, because the left is vacant. Okay, so this is not a complete binary tree. So what we have to do is we have to insert 11 to the left side, and then we have to insert the next element to the right side. So these are some rules for complete binary tree. So let's understand again. So for complete binary tree, what we have to do, first the levels will be filled, and then to the last node we have there should be no vacant places. Okay, so all the left side nodes are completely filled. So these both conditions are the for the complete binary tree. So now I think we have understood what actually the complete binary tree is, and now let's move to the question part. Okay, so now we are going to understand what actually the question is. So suppose we have been given one complete binary tree. Suppose I have taken the one example, that is 1, 2, 3 and 4, 5, 6, 7, 8, 9, 10. Suppose this is example, and what we have to do is we have to insert one element. Suppose we have to insert 12. Okay, so what we have to do is we have to insert that element, so the 12 should be inserted in this position. So this is what actually we have to do. We have to do the insertion in the complete binary tree. But what is the main thing is we already know how to insert a node into a tree. We already had done this, but the important part in this question is that we have to do this operation in constant time. Okay, so the time should be constant. So this is the main part of this question. That means we have to take the constant time to achieve that operation. Okay, so now we are going to understand like how can we do this. So before doing this, first what I'm going to do is I'm going to take one test cases, and then I'm going to understand this, how can we achieve this. So let me take the test cases. So this is our test cases, and let me take this and let's understand it now. Okay, so these are the operations. So what we have to do, we have to do the three operations. So these are the operations. So these are the number of operations, that is CBT, insert and get root. In insert operation, what we have to do, we have to insert that particular node. So we have to create the node and we have to insert in this tree, and this is actually our tree. So we don't have to create the tree. Okay, so tree is already created in our snippet. Okay, so what we have to do, we have to simply do the insertion part. So we have been given three things, that is one CBT inserter, constructor, and the second thing is insert, and the third thing is get root. So we have to implement these three things. This is a simply constructor in which we have been given root, and insert we have been given val. Okay, so in CBT inserter, that is simply a constructor. So if we want to use this constructor, so we can use this. And in insert, what we have to do is we have to write the code for insertion. Okay, so we have to insert in this particular tree. Okay, so we have to insert the node in this particular tree. And the third thing is, that is get root. So what we have to do is we have to return the head. Okay, so let's see for this case, for this default test case. Okay, so first I'm going to create this tree, that is 1 2 3 4 5 6 7. So we have constructed one tree and we have been given this root. Okay, and what we have to do is we have to insert 8 over here. So where the 8 is going to insert, 8 is going to insert in this position, so to the left side. So this is the point where we have to insert. And what we have to return in insert, see, inserted in 4, that means we have to insert the parent node where we are going to insert the element. Okay, so we have to insert in 4th node. Okay, so we have to insert this particular value. Okay, so this is what we have to return in case of insert, while inserting. Suppose we have to insert 10. So what we have to return, we have to return 4. Okay, suppose the next operation is again insert, that is we have to insert 20 over here. Okay, so what I'm going to do is I'm going to add 20 over here, and now we have to return 5 because we are inserting in this node. Okay, so this is actually what is the demand of this question. Okay, and in get root, what we simply doing, we are simply returning this root element and it is going to print our tree. Okay, so this is what we have to do. So now let's see how we are going to achieve this problem in constant time. So this is the main part, that is we have to achieve our insertion in a constant time. So let me take one tree. So I'm going to take one tree, that is 1 2 3 4 5 6 7 8 9. Suppose this is our tree. Now what we have to do is we have to do in constant time. So we have to use the level order. Okay, and what I'm going to do is I will take one variable. The variable name is NIP. And what is NIP? NIP is actually the next insertion point. Okay, so NIP means NIP is a variable of a node type, of tree node type, and it is always pointing to that node in which we have to add our new node. Okay, so in this case NIP will point to the 5 because our next node is going to insert in this position. Suppose there is already 2 child. Okay, now NIP is going to point this node. Okay, so what we have to do is we have to update our NIP. So we are going to do this updation in place of constructor. So we are going to use our constructor, in which what we will do is we are going to update our NIP value. Okay, so now in when we will create one object, so our NIP is going to point in this position. And while insertion, what we will do is we are simply going to add the child. Okay, we are simply going to add the node into our NIP, and we are also going to update our NIP side by side. Okay, so this is what we have to do. So simply what I'm going to do, I'm going to tell you how we are going to update our NIP. So for this, what we are going to do is I am going to traverse the level order. Okay, so we have already seen how to traverse the level order. So I'm going to travel a level order. Okay, and then I'm going to find out our NIP. So if any particular node doesn't have left child or else right child, then we have found our NIP. That means the next insertion point. So in that particular case, our next insertion point will be 5. Okay, so we simply have to find our NIP, and in insert function we are simply have to update, simply have to attach a new node of that particular value, and we are also going to achieve update our NIP value also if it is going to update. Okay, so let's see. So how we are going to do? So for this we have to use our level order. Okay, so for level order we already know that we use the queue. Okay, so we already know this. So we have to use the queue, and this is our root element. So first what I'm going to do, I'm going to push the root element into our queue, and then I'm going to traverse. Okay, so I will use one while loop for traversing, and first I'm going to pop this. I'm going to store this node into one variable. Okay, and if I'm going to check it, if that top node top of left is not equal to null, it is not equal to null, then what we are going to do, we are going to push the node into our queue. Okay, so the left is not equal to null, so we are going to push it. Again I'm going to check for the right also for this particular node. Again it is also not equal to null, then we are going to push 3 over here. Okay, we are going to add the right element also, right node also. Then what I'm going to do, in the second iteration I'm going to check for this. I will pop this element. Okay, now I'm going to check for this case. So if 2 of left is not equal to null, yes, it is not equal to null, then we are going to add the node into our queue, and then I'm going to check for the right side. So right is also not equal to null, then I'm going to add this particular node to our queue. Okay, then in the next iteration it will point to 3. That means we are going to pop this, and now our top is actually this element. Okay, so now I'm going to check for this case. So left is null or right is null. So both of them are not null. So what we are going to do, we are going to push 6 and 7 into our queue. Okay, then our top is going to become 4. So what we are doing, we are simply doing our level order traversal. Okay, so we have already done the level order many times, so I think you have this idea about this. Okay, so now I'm going to check for the 4. So left is not null, so we are going to add that node, and right is not null, then we are going to add that particular node. Okay, now our top will become this 5th element. So now our top is this, pointing to this element. Now I'm going to check for this. So if the top is equal to null, that means now we have find our insertion point. Okay, so next node is going to insert in this particular position. So now in this case we have found our NIP. Okay, so this is our actually the node where we have to insert our next node. Okay, so what we will simply do is we will simply mark this position, this particular place as an NIP, and I'm going to break it. Okay, so let me highlight this NIP. Okay, so now we have found our NIP, and now I'm going to break in this case. Okay, so now we have done our constructor part. Okay, so now this particular code we are going to do in our constructor. Now we already have our NIP, and now we are going to insert the next value, that is we are going to insert 10. Okay, so there will be two cases for insertion. There will be two cases. So we are having our NIP value. Okay, so we are having one NIP value. So there will be two cases. Suppose 5 is there. Okay, and the second case is its children is null, which is in this case when you will see it, the both the children are null. So the second case is if any one children is not null, that is 5, and suppose the 10 is here. Okay, so this is the second case. So there will be two cases. So if the NIP have no children, or else it has one children. The two children are never be possible in case of NIP, because NIP will only point to that particular node where it has where we can insert any particular node. Okay, so it is only pointing to that node where we can insert any node. So now our NIP is pointing to the 5. So now we have two cases. So let's see for both of the cases. Now we are going to insert the 10. Okay, so if we have to insert the 10, so first we are going to check for NIP. We are going to directly check for NIP. Okay, so now we already know our next insertion point. So we have to insert in 5. Okay, so first what we are going to do is we are going to check for left side. So if NIP of left is null, that means our NIP will only remain the same, because we have one vacant place. Okay, because we have one vacant place. Suppose we have inserted to the left side, but we have the vacant place to the right side, so we are not going to change our NIP. Okay, so NIP we are not going to change it. But in this case, suppose we have to insert 11 over here, so we will insert 11, and now we have to change our NIP, because our NIP will become this place. Okay, if we have inserted both the child, so in this case we have to change our NIP. Okay, so we also have to update it side by side. Okay, so when we are doing the insertion, so we have to insert the node, as well as we also have to update our NIP. Okay, so let's see for this case. So now we are going to insert the 10. Okay, so we are simply first we are going to check for NIP of left, which is null. So we are going to add a new node to the right side, to the left side, sorry. 10 is going to insert here. It is going to show like this, and what we are the second step is we have to insert it into the queue. Okay, we have to add that particular node into our queue. Okay, suppose we have to insert 11. Okay, now this is our second case. Okay, that we already have one particular node. So if left is null, which is false, so we are going to for the else condition, that is the left is not equal to null. Then in that case, what we are going to do is we are going to attach a new node to the right side, and we are going to add that element to the right side, and we have to shift our NIP. That means our next NIP will become, our next NIP is going to become this topmost element of the queue. Now this is our NIP. That means if I am going to show you here, now it is going to point out in this position. Now this is our new NIP. Okay, so in right side, if its left is not equal to null, then in this case we have to change our NIP. Okay, so this is completely the how we are going to do our insertion, and we have already seen like we are achieving this this operation in a constant time. Okay, so now I think it is clear. So now we are going to see the our coding part, and then let's understand this. So we have to code this in Java. Okay, so these are our three things which we have to complete. Okay, this is our insert function, this is our get root function in which we have to return our head, and this is our CBI inserter constructor. But actually this is not a constructor, but it is acting like a constructor, because the class name of this is main, and this is our main constructor, which is actually calling the one function. So indirectly it is a constructor. Okay, so treat this function as a constructor. So in this, what we were doing is we were updating our NIP, and in insert we were adding node and update NIP. Okay, and in get root we are simply returning return head. Okay, so these are the operations which we were doing. So for NIP, what we have to do is, first we have to create some global variable, that is array, that is q. So let me create q of tree node, new array tq. Okay, so we have created one tree node, and we also have to create one NIP, and the next thing which we have to create is head. Okay, so these are the global variables which we have to create. So we have done this. Now we have to do the level order traversal. So for level order, first we have to add the element into the queue. So first add the root. Okay, and the next thing which we were doing is, I'm going to use a while loop, a infinite while loop. Okay, and when we will find that NIP, then what we are going to do is, we are going to simply break this loop. Okay, so this loop is going to update our NIP and it will directly break it. Okay, so I'm going to use while true, that means it is an infinite loop, and now I'm going to do the operation. So first thing what we were doing is, first I'm popping the element and storing into one variable, then I'm checking for the left side, and if it is not null, that means we are simply adding it, and then we are checking the right side, and again it is not null, then we are simply adding this. Okay, and if it is null, then we are simply updating our NIP and we are simply breaking it. Okay, so let's do the same thing. So first I'm going to pre-node top and I'm going to pop it. So for q we use the remove. Okay, so I have removed the element. Now what we are doing, if top of left is not equal to null, if our top of the left is not equal to null, then what we have to do, we have to simply add that particular element into the queue. Okay, so I'm going to q dot add top of. Okay, so I have added our left element. Else what we are doing, suppose our left is not equal, left is equal to null, that means we have found our NIP. So NIP is going to point the topmost element, that is NIP is going to point out this element, then we are going to break it. Okay, so if it is true, then we are going to update our NIP and I'm going to break this. The same thing is going to happen for the right side also. Okay, so this is for the left side and the same thing is going to happen for the right side. So simply I have to change one thing, that is to the right, and top of right, and the same the else all the things are same. So now we have updated our NIP. So now the NIP is pointing to the next insertion point. Okay, now we have to do our insertion part. So let me minimize this, and I have just simply forgotten one thing, that is head equal to root. First I have to point the head to the root element because we have to return it in there. Okay, so now in insertion what we have to do is, there are two cases. While insertion there are two cases, that is, the first one is equal to if the left is null, and the second case is left is not equal to null. So there are two cases. So now we already have NIP, so we simply have to update our NIP. Okay, and what we have to return in this case is, we have to return the NIP value. Okay, that means we have to update this value, we have to return this value. So first what I'm going to do is, see, in this case our NIP is not changed, So we can easily return our NIP value. But suppose this is the case, so now our NIP is going to change. So now our NIP is going to 0.6. So we have lost this value. So what I will do is I'm going to store this value first. Okay, so first I'm going to store this value. NIP val, that means NIP dot val. First I'm going to store this value. So we have to do this in constant time, and we already have this NIP. So we have to directly insert that node. Okay, so first I'm going to create the two cases, that is if NIP dot left equal to null, that means it is a first case. Else it is a second case, that is left is not equal to null. Okay, so this is our second case. So if it is a first case, then what we have to do, we have to simply attach a new node to the NIP of left. So I'm going to simply attach the NIP dot left equal to new pre-node, and I'm going to assign it with val. Okay, and second thing which we have to do is we have to add that particular element into the queue to maintain our in order. Okay, so queue dot add that particular node, that is node dot left. Okay, so now we have done our first case, and what is our second case? We have to do the same two step for the second case also, but the next step is we also have to update our NIP. Okay, so we also have to update our NIP, and what will be our NIP? NIP will be the topmost element of a queue. So we have to pop that element and we have to store it in an NIP. Okay, so let's do the same thing. NIP of right equal to new pre-node val and queue dot add node dot right. And the next thing which we are going to do is I have to update our NIP. NIP will become queue dot remove. Okay, and in the end we have to return NIP val. Okay, so now we have also completed our insert function, and the next thing is we have to simply return the head. Okay, so we have to return the head. So let's check for the compile time errors. So it is error node of queue of node of left, so 68. So in a 68 line, so it is here 68. So it is actually the NIP of left. Okay, and it is also NIP of right. Okay, so let's run it now. Now it is accepted. So let me check for all the test cases also, whether all are running. So all the test cases are running fine. So now I hope you have understood this video. So thank you guys for watching this video, and we will meet you in the next video.